All right, good afternoon, everyone. Sorry I'm not there today, but we will get through everything just fine, I think. And if it all works out, you might have some time at the end for kind of free time or working on some of your missing assignments, okay? So it is National Burrito Day today, and what do I have to say about that? Yum, they're delicious. So if you are a fan of burritos, go ahead and enjoy. It's the first Thursday in April every year. So I usually put down homework questions, but obviously I'm not there, so I put down homework comparing. So what I'm going to have you do is compare your homework answers to everybody else's, and then maybe get some help on figuring that out. And then you'll pause the video and do that kind of thing together, and then if there are questions, you can help each other, and then we're going to go back to our notes. And have you do that. So I'm going to show you right here. I did post this on Canvas, but this is the answer key for the homework that you had. And so I want you to take a look at that, compare. You can maybe pause the video. It's weird for me to pause and then you can pause the video and then move it if you need to. So there's the first 6. Once you're good with those, then these are the last ones. And I do kind of want to call your attention to 11 and 12. So I'm going to let you pause the video and look at those. But we're going to kind of talk about what the difference is between 11 and 12. Okay, so if you had any questions on 1 through 10, maybe we should have you help each other out. But I'm going to go ahead and look at 11 and 12 here. And I want you to notice, we did one of these right at the end of the notes the other day. But the biggest difference here is that in both of these, I don't have just an x squared or just a m squared or whatever. I have a 2. And really what that means right now for me is that I need to look for a GCF. Would it make sense to you that the GCF of number 11 is 2? Okay, so that means I'm going to take the 2 out, and remember I'm dividing each one of those terms. So when I take 2 divided by m, or 2m squared divided by 2, I get m squared. When I take this negative 30m divided by 2, I get negative 15m. And when I take 100 divided by 2, I get a positive 50. So that's got to be my very first step. And once I do that step, then I can think about the smiley face. So I'm going to write my smiley face. Look, he's so happy right there. And remember that this GCF of 2 has to come down and be part of my answer. Okay? So then what I'm going to do is I'm going to start at the first term. That's an m squared. So that means I'm going to break that up and I put that in the first spot. So m and m. And then I go to the last term, which here's 50, and I'm looking for factors of 50. So 1 in 50, 2 in 25, let's see, 3 or 4 don't go in there, 5 times 10, and I think that's all. And remember, we're trying to make that add up to this middle term. We want that to be a negative 15m. So which of those give me the opportunity to make a negative 15? Hopefully you are saying that it's the 5 and the 10. So if I put a 5 in here and a 10 in here, and it really doesn't matter the order that you do that, if you put the 5 first or the 10 first, and we're going to multiply that. So the 5 times m is 5m. That's what this little smiley face tells me to do. Or I kind of think of that as the nose. But this is the smiley. M times 10 makes 10m. And I could make those equal to my negative 15 if both of those are minus. So I should have a minus in both of those. So negative 5 and negative 10. And so really this is my answer right here. And if you compare that to what we have there, sure is. Okay. It's funny, in the other one I put the 10 first. So you see it doesn't matter because they mean the exact same thing. I still have an m minus 5 and I still have an m minus 10. All right, so number 12 is really, really similar to that, right? What's the GCF going to be on number 12? We'll go a little faster on this one. Should be 3. So if I pull out the 3, That gives me an x squared plus 9x plus, what is that, 14? And then again, that GCF comes along for the ride, but I'm going to break up my x squared, and I'm going to find factors of 14. And that's all I have, and I want to get 9 when I do this smiley face, right? So I'm going to use a 2 and a 7, because those would add up to the 9x if both the 2x and the 7x were positive. And that would be my answer. So hopefully that makes sense. If anybody's struggling, I know there are several of you who know what they're doing. I've talked to already, so, help out. Okay, be good Samaritans, please. Once that's done, you can, so pause the video if you need to. Otherwise, let's go back to our notes then. And we're actually we're kind of going backwards. Now we're into 10.4 notes. So there is a method to my madness here, guys. There's a reason why we did 10.5 before we did 10.4, because they really do go together. So what I want you to see on these notes, if we're ready to go, is that I, again, have put this word in solving. And we've talked from the very beginning that solving means x equals, okay? So this is a little different than getting an answer that looks like that, right? There's no equal sign in anything I've done. So we're still going to be doing the same idea, the same thing, but we're going to end up with an equals at the end. So we did talk about standard form of a quadratic equation last chapter, in chapter 9. And a quadratic equation, if you remember, really means x squared. And my standard form is written as ax squared plus bx plus c is equal to 0. Okay? Now, that quadratic equation can be then written in what we call factored form. Well, guess what factored form is, friends? It's what we've been practicing right here. So all of these problems are in standard form. They don't say equals 0, but they still are in standard form because I have an ax squared, I have a bx, and I have a c. All right, so what do I do when I put it in standard form? It is really the product of 2 or more factors. So the product means that I am multiplying. And you can see in this example, this looks like something that I may have gotten by using smiley face, okay? And now it's in factored form because I have the x plus 6 as a quantity that's being multiplied by the quantity of x plus 2. So I do have a product of 2 factors there. And the difference, again, is now I set that's equal to 0. Well, 0 is a special number, okay? And so when I'm solving one of these, we're going to use what we call zero product property. And I know you've probably never heard that before, but you know this. The zero product property says that if I multiply 2 numbers, so if I take A times B, so that's what this says right here, A times B, and my answer is 0. The only way that's true is either A must be 0 or B must be 0. Right? Because if I say to you something like 5 times something equals 0, the only way that's true is if my something is 0. So when I multiply by 0, the answer is automatically 0. And we know that. We just didn't know it was called the zero product property. Well, that comes in really handy for us when we're going to go to the solving. So let's take a look at that part. So right here it says, solve this equation. And number 1 is x minus 5 times x plus 2 is equal to 0. So what I notice is that these 2 things are being multiplied. They're a product. So this is already in what I'd call factored form. So factored form really means, right, that I have two things that are going to multiply and my answer is going to be 0. So either one of two things has to be true. Either x minus 5 must be equal to 0, or x plus 2 must be equal to 0. And so when it's in factored form, I literally am just going to split those two things up, and I'm going to say, well, let's solve those then. So I would here get x alone by adding 5. It's that easy. So one of my answers, one of my solutions, one of my x equals is that x is equal to 5. On the other side, to get x alone, I would subtract 2. So that says x is equal to -2. So technically speaking, I could put the word or there if I want to. And that just means like the answer to this is either 5 or -2. Now, just like always, we are able to check our work, okay? And so I'm not going to ask you to check this all the time, but sometimes. And so when I check this, I will have to show this twice. So I'm saying right here, I'm going to replace the x with 5. Okay, so in my first thing, x is going to be 5 minus the 5 times 5 plus 2 is equal to 0. Because all I did there was I looked up here and I saw, well, there's where my x is and there's where my x is. I'm replacing that x with the 5 that we said right there. So what happens when I do that? Well, what is 5 minus 5? That's a 0. What's 5 plus 2? That's 7. Well, sure enough, if I take 0 times 7, I do get 0. So that checks out. That means x equals 5 could be an answer. Okay, now I could check the other side. So the same thing's going to be going on here. Here I'm going to replace any x's now with -2. So that's -2 minus 5 times -2 plus 2. And we're going to say, could that be equal to 0? So again, I'm just taking, right, this -2 and I'm replacing it with those x's. That's going right here. Okay, and then I'm saying, well, what do I get? Well, -2 minus 5 is actually -7, but -2 plus 2 is 0. So sure enough, when I multiply -7 times 0, I do get 0. So both of those answers work, and that's how I can say that. Okay. Did we lose? There's number 2. Looks a little different than yours. Okay, so for number 2, I want you to notice that at least one thing is quite different. I have this number 8 out in front. And that 8 out in front is still being multiplied. But there is no x with the 8. And that means that I can't solve that part. I can't solve a part that doesn't have an x. Because I can't get x equals if there is no x. So technically speaking, I should recognize that maybe as a GCF, right? Sometimes we have a GCF that sits out in front. So a GCF wouldn't get solved. It's just taking out that x. Now, I still do have two other quantities that are being multiplied and set equal to 0. And again, this is still in factored form. So what do? I take each one of those and I set it equal to 0. So 2x minus 1 could be equal to 0, and x minus 7 could be equal to 0. Now, the one on the right seems pretty simple. I'm just going to add 7 to both sides. So that says that x could be equal to 7. That's one of my possibilities. Okay. On the other one, we do have a little more going on. So I'm going to first add the 1. So that's going to leave me with a 2x plus 1. Remember, we've solved things like this for quite a while. And then we're going to divide by 2 because that's opposite operation. So x is now equal to 1/2. So now I'm saying that my answer for x is either 1/2 or positive 7. And again, if I wanted to check those, I would just have to go with my original function and replace those values, okay? So I'll show you what that looks like. In the first one, I'd have 8 times 2 times 1/2 minus 1 times 1/2 minus 7. And we're supposed to say, does that equal to 0? Right? So I really just replaced these x's with the 1/2. That's what I did. And then I'm going to simplify. So this is, 8. So I've got my 8 there. When I multiply 2 times 1/2, that's really a 1 minus 1. There's my 0. So as soon as I multiply anything by 0, don't I know that answer is going to be 0? So I'm done. And that's going to be very similar on this other side. I would again replace, so I'd have the 8, 2 times 7 minus 1 times 7 minus 7 is equal to 0. And I could recognize right here that that's going to be equal to 0. And therefore, whatever I get here, I don't care what these numbers actually are, when I multiply it, I get a 0. So we don't check things very often. We don't have to check them, but if you want to, you certainly can. All right, well, let's keep going. So another way to look at a factored form is something that looks like this, where I actually have like a repeated factor equation, where this right here says that I'm going to take 3m minus 5 squared. What does it mean to square something? It means to multiply it by itself. So that really turns into 3m minus 5 times 3m minus 5 is equal to 0. Now that's what it means, okay? But because these things are identical, you really only need to set one of those equal to 0. Okay, so if I just take one of those and take 3m minus 5 set equal to 0, if I add 5 to both sides, and then I'm going to divide by 3, so m is now equal to 5/3. So I really only get one answer for this, because if I set this one equal to 0, I'd be getting the exact same thing. Makes sense? Okay, so that's still a quadratic equation because I still have something squared. Sometimes this shows up a little differently. It actually shows up in a cubic equation. So cubic, if you recall, means x to the 3rd. So how do I know this is cubic? Check out what I have. 1, 2, 3 things that are being multiplied. And so really what that means to me is I have 3 x's and I need to set all 3 of those quantities equal to 0. Now maybe you could pause the video and set each one of those equal to 0 and see what you get for your answers and then come back. All right, so let's see what you did. I would have said x minus 3 is equal to 0. So if I add 3 to both sides, I get my answer, x equals 3, that's one of them. 2x plus 5 is equal to 0. I would subtract a 5 from both sides, and then I would divide both sides by 2. So x is equal to negative 5 over 2, or maybe you recognize that as negative 2.5 or 2.5. That's correct. And the last one, I'd say x plus 7 is equal to 0. So I'd subtract a 7. So x is equal to negative 7. All right, so all of those are it. It appears as if we have some kind of team outside doing some counting. So if you hear that, I apologize. That's kind of funny. I don't think they know I'm in here making a video. Anyway, okay, last part. So This is funny because this actually, if we flip-flopped it, we'd be using 10.4, but technically we're really using 10.5 here. So we're using the process we learned in section 10.5, what we did for today. So we are going to be solving, which still means x equals, but we're going to be doing this by factoring. And right now what I want you to think of for factoring is that smiley face factoring, right? So in order to solve by factoring, there are some things that must be true. We must have this equal to 0 before we start anything else. So in number 1, is that quadratic set equal to 0? Yes, it is. Right there it says equal to 0. So if that's the case, I can jump right in to my smiley face. But here's the difference, guys. It's still equal to 0, okay? So now we've been working with things in factored form. Now I have to put it in factored form. So to put it in factored form, we're going to do exactly what we did for today. We're going to start with that first term, x squared, and we're going to break that up. So that's going to be an x and an x in the first spot. Okay, then we're going to go to the last term and we're going to think of factors. So factors, 1 times 10, 2 times 5. Anything else multiply to make a 10? No. And my goal is to make this, say, a positive 7x. It's my middle term. So again, I'm going to pick the factors that give me that opportunity. What do you think? I can hear you kind of saying 2 and 5. So when I put that 2 in, right, this is going to give me a 2x when I multiply and a 5x when I multiply. And that would give me a 7x if both of those are positive. So I'm going to put a plus sign. Now, as far as this went yesterday, we were finished right there. But this time we aren't finished. Does anybody know why? If you said it's because we're supposed to solve this for x, you're right. So what do I need to do? I need to take each one of these and I need you to set it equal to 0. Because again, we put this into the form of all these problems up here. Okay, so x plus 2 is equal to 0. Or x plus 5 is equal to 0. And these are pretty simple problems. We subtract the 2, so x is equal to negative 2. If I subtract a 5, x is equal to negative 5. So right there, now I'm done. So it's the same as what we've been doing, but it's just one extra step. Good. Okay, number 2, I think there was a typo in number 2. I'm going to have you change that. So let's have you write down m squared minus 6m is equal to 27. All right. If that's the case, okay, the first thing I'm going to ask myself is this set equal to 0? No. So in order to make this equal to 0, I have to get rid of this 27. So I'm going to subtract 27 from both sides. And when I do that, that leaves me with an m squared minus 6m minus 27 is equal to 0. I'm just writing all those things down because none of these are like terms. M squareds are different than m's are different than numbers. So I can't combine anything there. I just have to write it down. Okay. Now I'm going to factor, right? So to factor, I'm going to again think of our smiley face, but our smiley face must be equal to 0 because if I have it equal 0 here, I have to be equal to 0 at the end. All right. If you want to pause the video and try it, go right ahead and then come back. All right. Hopefully you pause the video. And what we're going to do is we're going to break up our first term. So m squared, that's going to be an m and an m. Okay. And then we're going to go to our 27. Now I notice this is a negative 27, which does mean one of those is going to have to be a positive, one's going to have to be a negative. Remember, I like to check that at the end. So I'm just going to think of numbers like 1 times 27 or 3 times 9. And I think those are my only factors of 27. Now, what am I trying to get to in the middle? A negative 6m. Okay, so if that's the case, which one of these is going to give me a negative 6 opportunity? The 3 and the 9, you got it. So I'm going to put in a 3 and a 9, whatever order you want, which will give me a 3m when I multiply and a 9m when I multiply. In order to get a negative 6, what would I need to have? I'd have to have a negative 9. So that means that I'm going to minus there and a plus there. Did you do that? Good. Okay, am I finished? Not quite. I'm going to have to take each one of these, m plus 3, set it equal to 0, and m minus 9, set it equal to 0. Then I'm going to subtract, so that's m equals negative 3. Here I'm adding 9, so m is equal to a positive 9. So those are my answers. Okay, hopefully this makes sense. If not, work with somebody else. I know that some people would understand this maybe more than others. And your homework is going to be this worksheet 10.5 with solving, and it's purple. And I also have an answer key for that posted. Okay? Okay, we'll see you tomorrow.